So what I want to start with is there are some other ways that we can describe directions of forces. And so I mentioned this when we were here last time, but the two particular ways that are different that we haven't talked about in very much detail yet are the idea of slope. So I'm going to go over that a little bit. And then the other one is the idea that you don't always have to measure your angles relative to the x-axis, right? So those are the two concepts I want to touch on real quick. And so let's think about for an object, this is an object, and it has a couple of forces, or let's just say one force applied to it. And let's say that that force goes up like this. It's usually our job, right, as engineers, we're the ones that have to establish our reference frame. And so let's say that we've established that reference frame. We might not know a whole lot about this, but let's just say I've established this reference frame because it aligns well with the direction of gravity, let's say, or something, right? But this is the reference frame that I have established. And relative to this reference frame, let's say that this force has a particular rise and run. And so I'll basically just write this as a rise, and I'll write this as a run. And let's say that this force has a magnitude overall of F. And what I want to do is split this force into two components, one component being parallel with the x direction, and the other component being parallel with the y direction. Okay? And it's based on knowing values for rise and run. Right now I'm doing it more in general terms, but in the actual problem you would know values for F and for rise and for run, for instance. Okay? Well, how would I go about splitting my force F into components knowing those pieces of information, F, rise, and run? Well, let me show you this. What we're doing as far as the geometry of it, or the trigonometry of it, is we are trying to figure out this side and this side for a particular triangle. All right? Is that what we're trying to do? We're trying to figure out those two sides? Okay? So the rise and run, that is actually kind of a triangle as well, wouldn't you say? All right? And the other side, I guess the two sides of the rise and the run, the other side of the triangle is the hypotenuse, right? So maybe I'll just abbreviate that with HYP. So we have the hypotenuse length, the rise length, and the run length. So a quick question for you. How does my blue triangle relate to my red triangle? They are, I think I heard someone say it, they are similar to each other. Okay? They're similar to each other. If they're similar to each other, what kinds of relationships can we write? Okay? They're proportional, right? The different corresponding sides should be proportional to one another, which tells me, for instance, that if I want to know the ratio of Fy to Fx, what can I do? Okay, it should be equal to the ratio of rise over run. All right, so that part's not too bad. What if I want to know, ultimately, what if I want to know something like Fx? How do I find that? Okay, I would say that, something like Fx over F is going to be equal to what? Okay, run over hypotenuse. All right, and so what does that mean as far as the actual value of Fx? Okay, it'll be F times the run. And real quick, how long is the hypotenuse? Okay, the square root of rise squared plus run squared. What if I want to know the value of Fy, so the y component of F? Fy over F is going to be equal to what? Okay, the rise over the hypotenuse. Okay, and that tells me that Fy is going to be equal to F times what? The rise over still the hypotenuse, right? It's no different as far as that's concerned. So you still have the square root of the rise squared plus the run squared. Okay? And so if you end up getting information about the direction of a force that is no longer an angle, it is instead a slope or rise and run information, you should be fine in terms of coming up with the components of the force, right? You can just use this method right here. All right, questions about that? Awesome. Now let's do the other one that might be a little bit confusing. The other one is you are not always going to get angles that are measured relative to the x direction. Sometimes you might get angles that are measured relative to something else, for instance, the y direction. So let's look at a case like that. So again, you have some kind of an object. That object, let's say we've established a reference frame, and then we show a force that's acting on that object, and we're given the angle measurement for that force. We're given that angle measurement relative to the y direction. Okay, so let's just say, I'll use a different letter here than theta, because theta we usually use for the other one. It's not that you have to use a different letter. I'm just using a different letter to kind of show that it's a little bit different. Okay? And what I want to know is what are the x and y coordinates, or the x and y components, I should say, of this force F. Well, where would I start if I'm trying to figure this out from scratch? Okay, I should probably set up the triangle, right? This force is the sum of two forces, one that's vertical and one that's horizontal. So this would be Fy, and this would be Fx. Okay, the other thing I'll do is I will go back and remember the thing that we have to remember above all. What are the definitions of my trig functions? Sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is opposite over adjacent. Okay? So let's just start, let's just start with sine. The sine is opposite over adjacent. That means that the sine of this angle phi is equal to, what is the opposite side to the angle phi? Okay? Yeah, so you'll see there that phi, it actually touches Fy, so that would be the adjacent one. The opposite one is the one that doesn't touch, which is the Fx. So we would have Fx over F is the hypotenuse length. Okay, so that is, all we're doing there is just using the definition of the sine function, which tells me that Fx is going to be equal to what? F sine of phi. What about the other one? What do you think it will be? Okay, f cosine of phi. How do I know that? Right, the other one here that we would have would be that the cosine of phi is equal to the adjacent, which would be fy, over the hypotenuse, which is f. Okay, and so if you have a situation like this where you have an angle that's measured relative to the vertical rather than relative to the horizontal, basically all you do is you swap your sine and your cosine. Okay, I'm always in favor of memorizing less, right? Not have as many things in life that you have to memorize. And so I'll show you here, the only thing I memorize in this situation is this. And the rest we can figure out, right? So that is how I approach this. Rather than memorize something like cosine always goes with x or sine always goes with y, I wouldn't do that if I was you. I would always look at the triangle and try to figure out which side is the adjacent side and which side is the opposite side. Adjacent is always with cosine and opposite is always with sine, right? And that will always work. You know, you don't have to memorize a bunch of cases, all right? Yes?
So for this problem, say the angle was given to you, subtract from 90 to use it.
Okay, her question is, could you just subtract this angle that's given, say phi, and say, let's just say down here you have 90 degrees minus phi. That's true, isn't it? Yeah, that's true. Okay, and her question is, couldn't you just do that and say that, you know, fx, for instance, was going to be equal to f cosine of 90 degrees minus phi? Is that valid? Sure, that's valid. Yeah, you can do that. Not a problem. Okay. Personally, I like to write less and do less math, right? And so I personally prefer just to look at the triangle and use the one that's the most appropriate just by direct inspection of the original triangle. But there's nothing wrong fundamentally with doing it that way either. Okay? All right, so that's all I really wanted to touch on going back to our discussion last time. I tell you what we're going to do next is I'm going to pull up Mathcad, and I'm going to do a little demonstration of Mathcad 15 for the solution of a couple of similar problems. Okay. So here's a problem we're going to deal with. It is two forces are applied to an eye-bolt anchor. All right. These are the two forces that are being applied. I tell you what, I'll go ahead and name them here. Let's call this F1. And this down here we'll call F2. All right, and what we want to do is figure out what is the resultant of these two forces acting on this anchor. Okay, and we're going to do this in Mathcad. So the first thing I want to do here is pull up my snipping tool so that I can drop it into Mathcad. Okay. Here is the Mathcad interface. One of the things you'll see that you can do in the Mathcad interface is you can copy and paste pictures. All right, that's handy because if you want to use Mathcad to completely do all of your homework, that's not a problem with me. I'm completely fine with you completing your homework in Mathcad. Okay, but you still need to have all of the things that are required in your homework. For instance, if you need a diagram to really describe something well, I'm not going to allow you to not put a diagram in there just because you're using Mathcad. You still need the diagram, but it's fine. You can put in a picture in order to get those kinds of things described in Mathcad. All right, so the first thing I want to show you here is this. We can define variables, okay? And what we do is we use a thing that's called the assignment operator. All right? What are some things that we might want to define as variables here? Okay? Probably all of our given values, right? That's, in my mind, I always take a problem like this and I split it up into things that we're trying to find versus things that we were originally given. What are some things we were given? Okay, maybe zoom in a little bit here so you can see what I'm typing. Okay, right down here, I'm going to type in F, and I'm going to put in F1. So here's the first big difference between Mathcad 15 and Mathcad Prime. It's how you put in subscripts. All right, I think there's a keystroke sequence. It's something like control underscore or something or other. I don't know. It's a big mess in Mathcad Prime. It's really easy in Mathcad 15. You hit the period, and you type in what you want as your subscript. Okay? The assignment operator you get by typing a colon. Okay? You type a colon, it puts in this character that looks like a colon and then an equal sign next to it. Okay? One of the trickiest things people have, and one of the biggest blocks to learning Mathcad that I've seen people have, is that we have several different kinds of equal signs. All right? And it's important to use the right ones in the right contexts. So this one right here, what this sign means is that whatever we put on the right side of the expression is going to be stored into the variable we put on the left side of the expression. Right? So this kind of thing happens in programming too. When you program your Arduino, you have two different kinds of equal signs there too, right? So you have just a one equal sign. What does that mean? It means store what's on the right into what's on the left. Okay? If you use a double equal sign, what does that mean? It says, I'm going to compare this one to this one. I'm asking the question, are these two equal? Right? So one is a statement, one is a question. Right? This is more similar to the statement, the put whatever's on the right into what I have on the left. Okay? So what do I want to put in there? $23 newtons. Okay? And this is going to freak some of you out a little bit. Can I just type in an N? Yes, I can. Okay? This is one of the great things about Mathcad is that it is units aware. Right? You can go ahead and put your units in for with your quantities, and all of that dimensionality is going to be evaluated live in your sheet. Okay? This is actually the blessing and the curse of Mathcad, because Mathcad is going to complain at you if you try to use inconsistent units with things. And it makes people frustrated often, right? But it's doing it because it's impossible. Like you can't add feet plus pounds, right? It doesn't make any sense. And so it'll complain at you if you try, all right? So what's another one we should enter? F, you hit a period to get 2, then you type a colon, and you put in 192 newtons. What are some other givens that we might have? Okay, angles. And one of the things you'll see is that I have over here on the right side a number of toolbars that are open. One of them is called the Greek toolbar. So I can get a theta just by clicking on theta there. Okay? If you don't have these up, there's a thing at the top where it says View, Toolbars, and one of the things that you can select is the Greek toolbar. Right there. Okay? So I put in a theta. I'm actually going to call that theta 2. Again, I'll hit colon, and I'll put in 75. Okay? If I just put in 75, what do you think this is? Okay, right now it's unitless quantity. Okay? If you have a unitless quantity that's measuring angle, how do you think Mathcad's going to interpret that? Yeah, it's going to assume you mean radians. So right now I have entered 75 radians, whether I know it or not. Okay? So what should I do if I want 75 degrees instead of 75 radians? Okay? Unfortunately, that's not a degree symbol. Well, fortunately, unfortunately, it's actually easier to type DEG than put in a degree symbol anyway. And this is what you put in for degrees in Mathcad. Okay, 75 degrees. What else should we put in here? Maybe I'll put in rise. That's a variable that I'll define here. Of what? 2. And a run of 3. And that basically takes care of all of my pieces of given information. So far, so good? So what have we learned so far? We've learned how to put in variables. We've learned that those variables can have subscripts. And to get a subscript in Mathcad 15, you type a period. Okay? You also have the ability to assign something into that variable using the assignment operator. The keystroke to get an assignment operator is colon. Okay? And then the last thing is when you put a quantity into these variables, you can put it in with units. All right? And that does take a little while for you to get used to the built-in units that it already has in it. All right? We'll use it enough to where you'll start getting used to it and having some different units that we might use. Okay, one of the things that's interesting here is that the unit systems are not apart from one another. So like you can mix unit systems if you want. Okay, you don't have to have things separated as long as you have units that are consistent in terms of what you are measuring. All right, so let's do this. What's our first step of finding a resultant? Okay, so maybe we need to figure out what maybe the x and y components are for each of these variables, or each of these forces that are being applied. Okay, so let's do this. Let's do F1 x. I'm going to define another variable here, and I'm going to set this variable up in terms of my previous variables. How do I get just my x component of F1? I take F1 and multiply by what? The run over, okay, what did I do to get, so let me back up here and say what I'm doing here. I'm going to assign this to be equal to the variable F1 multiplied by, this is very important, you cannot assume it's going to multiply or divide unless you type those characters in. So right here I'm going to type in a star, which is above the 8 key on your keyboard. So I'm going to type a star to do a multiplication. Okay. I'm going to type in the variable name run. So I'm going to multiply by the run over what? Based on what I just went over just a few seconds ago. Okay, square root. We can get a square root. It is the backslash key. Okay. So we put in a square root. By the way, if you don't want to remember that, there's a bunch of options that are up here in this calculator toolbar, and one of them is a square root. So you can do that, or you can try to remember that you use a backslash key. Okay. And what do you put in here? Okay. Rise squared. Okay. How did I get that squared, you think? Okay. There's a caret here. So if you hit shift and right above the 6 key, you have a little caret symbol, and you type in a 2. Okay. The other thing that's really nice here is sometimes you want to apply your next few keystrokes to different amounts of your previous text mathematically. So if you want to cycle through the different options, you can hit your space bar. And what you'll see is that as you hit your space bar, it changes how much of this stuff you're going to apply your next few keystrokes to, right? So what do I want to pick here? Rise squared. And I used my space bar to cycle through the different options. Okay. Now I'm going to hit plus what? Run, again, caret 2. All right? What I have done with this statement is I have taken those variables, I've performed that calculation, and I've stored the result into f1x. How do I kind of confirm that I've really done that? Well, let me show you another equal sign. Okay? I can type f1x again. And if you just hit a plain equals, no frills, no nothing, just hit plain equals, it gives you a different looking equal sign. Okay? This is called the evaluation operator. All right? It's different than the assignment operator that we used a second ago. The evaluation operator basically is an instruction to Mathcad that says, hey, evaluate that expression I just put in there and tell me what the result is. Okay? Which is what it did. It says f1x is equal to 19.137 newtons.
Mine's not giving me that equal sign.
When you type equals, are you using prime?
No? No, on 15, you press enter and it doesn't.
Okay. If it does not give you that equal sign, what it means is that you might be typing it different than you had assigned it, right? Because what happens here is, even though the correct keystroke to get the assignment operator is a colon, if you type an equals when you have a variable name on the left that you haven't used yet, then Mathcad is smart enough to go, I think you meant colon, right? Because you haven't used that variable yet. And it says, I've got nothing to evaluate, so I'm going to assume that you mean assign, right? Here's something that this might be another thing that might be giving y'all some headaches. Here's something that's very important to know about Mathcad. The things that are on the page, it matters where you put them. Okay? The steps that happen on your worksheet happen in a particular order, and the order is this. It first goes left to right, then it goes top down. Okay? So if I look at my sheet right here, it does this first, then this, then this, then this, then this, then this, then this. Okay? That's the order in which it does each of these steps. Watch what happens if I take this entry and I move it up just one space. What happened? Okay? So what happened is, this is now above that. And so this hasn't been defined yet in terms of where this is located on the sheet.
So priority takes over top. Priority is top of the page, and then it goes up there. It's like reading.
Yeah, so that is a fair way to say it. First, like if something's above it, it doesn't matter if it's to the right of it. Okay, because it's like it's on a previous line. Okay? So there's that. How do I figure out my y component of my f1? I'll tell you what, rather than type all this stuff, I'm always a fan if I can copy and paste. Okay, and so what do I do different here? Okay, there's a few things I want to change. I probably want to change the name of this to f1y. I want to change this up here to what? Rise. And then where I evaluate this, I want to evaluate f1y instead of f1x. Good. All right, let me show you another couple things. These don't matter in terms of the calculation, but these are ways that I format the sheets that I do so that it helps me remember what I'm doing. Okay? Anytime I put in given information in my sheet, I like to put sort of a marking on that so that if I put this sheet away for 10 years and I come back and I try to open it, know which be able to update with other information if I'm solving a similar but different problem. Does that make sense? So you want to be able to know which thing you might want to update the values. And so what I do for that is I change the properties of these, and there's nothing special about this. This is just a scheme that I've come up with for me. You can do it different if you want. But I like to highlight all the things where I'm expecting to put in information maybe that's different someday. I put in a highlight that says, here's where I can do that. Okay? Another thing that I like to do is to show my results and kind of really highlight what those results are. And the way I do that is by boxing my answers. Okay? And I know it's not showing up real well right there. I think that's an artifact. Something's weird with how it's showing on my screen. But I went in and I actually showed borders around those answers. And that's a way to kind of, draw the eye to things that are results of the calculations that you've done. Yes, sir? Okay, so I first selected, you select the field. So I used a box to kind of select all those fields. Right, so I kind of clicked and dragged to make a box to select all those fields. Right click, go to Properties. To make them yellow, I clicked on Highlight Region. You don't have to use yellow. It gives you all these other color choices. All right, yellow is the default though, so that's easy. So I've highlighted those fields. As far as these other ones, it's a very similar process. First you select those fields. Go to Properties. And there's another checkbox here that says Show Border. Okay. So again, there's nothing about that that's like you need to do that in order for the calculation to proceed, but that's just, habits that I've gotten into over the years of using Mathcad that make it easier for me to remember what I was doing. All right, if I try to come back and open a sheet later. All right, so there's the first half of the problem. What's the next thing we got to do? Got to deal with F2, right? So what do I do for that? F2 x will be what? It'll be equal to F2 times, okay. All right, I would say that would be a good way to approach it. This was said, you take that times run over the hypotenuse. We could do it that way, but that doesn't match really well with how the information is given in the first place. Right? We're given an angle, so let's use the most direct way to use that angle to figure out the x component. Okay? And it's tempting to look at that and say, I'm going to use the cosine of 75 degrees. Is that right or wrong? Okay, that's wrong. Why is that wrong? Yeah, this angle is measured relative to the y-axis. What I really want to do there is I want to figure out what is the adjacent or opposite component relative to that 75-degree angle. It's tricky, isn't it? Okay. So what do we do? Okay, think about this little triangle right here. It's a triangle that's made like this, right? And you know this angle right here. You're trying to figure out that component. Okay, someone over here wants to take 90 degrees minus 75 degrees and make everything easy. All right, it's not wrong. We could do it that way, but I'm trying to get you to see how do you look at this angle and know which component is opposite versus which component is adjacent. Okay, I would say that the one we're trying to get is the opposite component because this is the little angle right here that we know, and that's going to get us this vertical component. Do you agree? Okay, so because we're trying to get the opposite component, which trig function should we use? Sine. And then we're going to do that of sine as sine of theta 2. Real quick, is my sigma, my plus and minus, am I correct in terms of being positive or negative? Okay, someone says yes, we're correct in terms of positive and negative. How do we know? Okay, sine of 75 degrees is going to give me a positive number, right? It's between 0 and 90, so it's going to give me a positive number. And I know that my f2x should be positive because it points to the right. Okay, so that part's good. And do we want to see what f2x ends up being? Okay, this is what f2x is. How do I figure out my y component of f2? Okay, same idea, but what do? We use cosine instead of sine. Okay, good job. So that was going to be my next question. This is right so far, but is my f2y pointing up or down generally? Does it point vertically, positive with the y, or is it opposite the direction of positive y? It's down, opposite the direction of positive y, which means that this isn't quite right. So what we need to do is go in there and put in a negative. All right, now what do we do? Okay, let's figure out what the x and y components are of the resultant. The x component of the resultant is going to be what? Okay, f1x plus f2x. And what is the y component going to be of the resultant? Okay, f1y plus f2y. Okay, we're good. We're doing just fine here. We're going like gangbusters. What's next? To figure out the magnitude, what do we do? Okay, we take the square root of the sum of the squares of these two components. Okay, quick question for you. See over here? What is that? It shows you a little green squiggly right there. I'll actually say something if I click on there. This expression redefines a Mathcad built-in unit. Okay, turns out R is used for Rankine. What is Rankine? Rankine is the U.S. customary systems equivalent of something like Kelvin. All right, it is an absolute temperature measurement. And so here's the thing. Do I care? I probably don't care in this sheet. But it's something to watch out for, right? You could be going along and you might decide, I want to use m as a variable, lowercase m. What do you think might be the problem with that? Yeah. Mathcad uses m for meters. All right. So, and this is actually one of the things that's different between Mathcad 15 and Mathcad Prime. It actually has a little bit different system of doing units in Mathcad Prime. But Mathcad 15, you just have to be careful not to redefine built-in units like this. All right. So what is R? I mean, you can redefine a built-in unit. You just need to be aware that you're doing it and make sure that it's not going to be a problem later in your sheet. All right? So there is the magnitude of my resultant. Okay? How do I figure out the angle of the resultant relative to the x direction? Okay? In Mathcad, I'm going to tell you what, I'll put in theta r, theta sub r for the variable that I'm trying to find. Okay? In Mathcad, in order to get inverse trig function, you basically just put the lowercase a out in front of it. What do you think that means? Atan. Arctangent, right? Of what? Ry over Rx. Okay, so theta r then is equal to this. Okay? I hear some people, there's some chatter going on over here. What's going on there? What is going on there? Okay? Yeah, it is giving it to you in radians, right? If you don't have units with it, it means it's using whatever the mathematical equivalent way is of measuring something, an angle without, units. What if you want it to show in degrees? You could do it manually, or you could just type in this little, it gives you this little black box right here. Type in DEG and it'll show it to you in degrees instead of showing it to you in radians. Okay. One of the nice things about having a units aware piece of software.
So what's the difference with what we just did in Mathcad 15 and Mathcad Prime?
There won't be much difference. Some of the keystrokes are different, for instance, to get subscripts, but that's about it. The rest of it is really pretty much the same for Mathcad Prime versus Mathcad 15. There might be other little things here and there I'm not thinking of, but pretty much the same for Mathcad Prime as Mathcad 15 for these steps, other than how you get subscripts. Yeah, one of the big differences of Mathcad Prime versus Mathcad 15 is how you do graphing. Graphing is, in my opinion, far advanced in Mathcad 15 relative to Mathcad Prime. Which is really sad, but that's the way it is. Okay. Then another big thing that we're not going to cover today, but there's a technique that's called a solve block. And how you use a solve block changed significantly from Mathcad 15 to Mathcad Prime. The idea of it didn't really change, but the specifics of how you implement it changed a little bit. Okay? All right. So this was example number 1. Okay, yeah, so I don't know specifically what's going on your screen, but if it returned K, it probably means that you didn't actually redefine R. I just used the assignment operator over here. I don't know if when you typed it, you may have done R with just a plain equal sign, something like this. Actually, I'll do it up here. R, is that what you're seeing on your screen? Okay. What that means is that you probably didn't hit colon, you probably just hit equals. All right? Colon is the assignment operator. Occasionally you can get away with hitting equals and it will give you the assignment operator if that variable hasn't been used before. Unfortunately, for this particular example, R has been used before because R is defined as Rankine. So if you hit R equals, it says, okay, I know what R is. R is about half of a Kelvin or so. All right, and that's not going to really work for us. So you're going to need to make sure you use the assignment operator. All right. I was thinking about doing another example. I'll tell you what, I'm not going to do the whole other example. But what I'll do is I'll show you what it was, and I'll leave it for an exercise for you to work on if you would like. This other example is this one. Okay? What changes here? Okay. We're using different units. I'll tell you what. I'll go ahead and put this in here. I will go ahead and do it. Okay. Select this. I'm going to drop it in my Mathcad sheet. Okay. This is the power of Mathcad. This is the reason I wanted to show this. Okay. The power of Mathcad is that once you've solved a problem of a particular type, your sheet is strong enough, usually, to handle things that are similar but slightly different. Okay, what do I need to do here? Okay, so F1, I might want to change that to 20 pounds. By the way, pounds, this is a big point right here. Don't put in LB. LBF is pounds force. And, you know, these are different units, right? One is a measure of mass, the other is a measure of force. If you want the measure of force, you need to have LBF. Okay, so I put in these two like this. What do I put in for theta 2? I could put in 40. What might be better? What if I put in negative 40? Why would I do that? Okay, it goes the opposite direction from the direction that I had before, right? So that actually kind of would make sense. What about rise and run? Rise is fine, okay, so we put in 5, yeah, but it's the right sign, right? Run, you might put in negative 2. Okay. Does that give us what we would expect as far as our force components? Oh, by the way, now it's still showing it to us in newtons. I don't like that. I'm using a different unit system now. What should I do different? Okay, if I go and type and click on the little black thing, the little black box at the end, I can change all of these units to what I want to see. The quantity really hasn't changed. The physical quantity hasn't changed. It's just that I'm showing it to you in a different unit system. Okay, do these seem right? Okay, they seem pretty good to me, right? All right, so then we go down here. Let me change this unit system. Let me change this one. And that one. Now what about my theta r? Okay, I still have it in degrees. Do you see any problem with my theta r? Is it in the correct quadrant? Wouldn't it be nice if there was a way to automate that? Have it give you the correct quadrant no matter what? Well, maybe there is. Atan 2. Okay. What is this thing? Atan 2 is kind of interesting. It is another function that's built into Mathcad. Instead of putting in a fraction, you put in your x and y entries. Okay, so you put in rx and ry.
That's just a comma separating them.
With a comma in between them. Okay, and what do we have here? Okay, this is again, it'll show up by default in radians. If I want to put that in degrees, I put it in like this. And I'm going to show that border. to indicate that that's my answer. All right. Does that seem better? Let me ask you this. What is 180 degrees minus 42.852 degrees? Maybe. All right. So that's a way of giving you the result, even if it's in a different quadrant. We'll give you the result directly. All right. Any questions on Mathcad before we move on to our next stuff? Yes. Okay. So if you were in the right quadrant, then you would have a positive Rx value. Right? You wouldn't have a negative Rx value. Okay? So I think your question is, for the last problem that we worked, would this work? Is that your question, basically, for the first problem we worked? Would this technique of using ATAN2 work? And the answer is yes, it would. All right. Be patient with Mathcad, okay? Mathcad is kind of unforgiving when you first start to learn it, all right? Be patient with it. It's one of those things that most people hate it somewhat whenever they first start it, and after using it, you begin to love it, okay? So just a little bit of time, let it percolate, and you might be surprised at how much you end up enjoying it.